Hello everyone. Today we will try to explain multiple linear regression. So in the previous video I tried to explain with the simple linear regression is only with one variable plus the class label. With gradient descent and also you can see how to update the parameters theta with an example. So someone will ask a question, why we need the linear regression? So suppose that you have a company and you would like to know, let's say this example, you would like to know how much profit you will gain if you spend, for example, amount of money in research and development, and for example in administration, and for marketing spend, and with this the company, for example in New York and any city. So this data set is 50 startup data sets. So for example, the first startup company spent this amount of money in only research and development, and this amount of money in administration, this amount of money in marketing, yeah, and they gain. This is the profit of this company. Another example, you would like, for example, to predict the house price based on some features, for example, like the size, number of rooms, and etc. And also predict the salary based on, for example, the number of years of experience, as you will see in the previous video. So now let's see, this is the general equation of the multilinear multiple linear regression. Theta 0 plus theta 1 x1 in this case it will be, in this case just as example, research and development, plus x2 administration, and plus x4 state. Now this is, for example, y hat is the predicted value. You will try with this equation, you will try to predict the profit. Now n is number of features, as we see here is we have 4 plus 5 plus the profit. Profit is not included here because we will try to predict the profit. And as we see here, these thetas, we have to initialize this value, and how to initialize these values and how to update it to make a good system or model. So now this is the main equation. So is there any way to make it small, for example? Yes, this is the next formula: y hat equal theta multiply x, and x in this case, x it will be x0, x1, x2 about to xn, and x0 here because it's only one, we don't add x0. And now this one, theta multiply x, it's a dot product, so if you multiply it you will get this equation. Now is there any way we can use it and get the theta values directly from the data? We don't need, for example, some other methods. Yes, for example, this formula is normal equation, but the main disadvantage of this method is that it takes much time for computing. So if you have big data, for example, millions of records or million of features, so in this case the complexity will be n power 3 to the power 3. And now assume that you apply this method, you apply this formula to extract or to find the theta values. Now let's say, for example, you have 5 features, and with 5 features it computed, it takes let's say 10 seconds. Now if you duplicate, for example, your features, for example, you have 10 features, you will have to multiply the time with 8. So it's horrible if you have a big data. So is there any solution to do it? Of course. gradient descent algorithm. Gradient descent, this is the gradient descent, it's a generic optimization algorithm. The basic idea or the main idea of the gradient descent is to change the parameters, these parameters, and change these parameters to minimize the cost, this cost. This formula will be used to update the parameters. For example, theta 0, and because we have from 0 to n, theta 0 of course will be updated, and here's the old value of theta I minus alpha. Alpha is learning rate, and this is a derivative, partial derivative. You can see this in the next slides, or I also explained it in the previous video of simple linear regression. So, and how learning rate has effect on this theta, we will see it next. So now again, gradient descent calculate how much the cost function will change if we change, for example, theta 0 and theta 1 and theta till n a little bit. So how to change how much the cost will be changed. Now this is the general meaning or explanation of the gradient descent. So assume that you are here in this top, top of the mountain, and you would like to go to the down. So, but unfortunately you cannot see anything here. You can see the slope around you. So whatever you see the slope, it's minimized. You can go one step down. So for instance, you go down, and this one, and this one, and this one, and you can reach this point. Now this is not the by the way, we are looking for the minimum, for the global minimum. For example, this one, it could be minimum, but this is not the global minimum. The global minimum will be here, and it could be in this point as well. So it's not guaranteed to have this or this, but gradient descent is minimized, guaranteed to minimize the cost. So now, as we see, here's the alpha and learning rate. So in this, as you can see in this figure, if we start from this point and change alpha, it's a small value, for example, and you can reach those global minimum, but it will take time, much time. So in the other meaning or the side, if we have a big or large rating rate, for example, assume that you are here close to the minimum value, but the learning rate is high or large. So in this case, you will go back, and you are far away from the minimum value. So the good idea is to have, for example, for the first n iteration, make learning rate is large value, and after that you can make it very, very small, and in this case you can guarantee that you will get the minimum cost, or you will minimize the cost, or you will find the global minimum. Let's say, for example, we need to after computing the cost, right? So for example, you will with this, for example, formula, you will find y hat, and now y hat is close to the actual value of y or not. We can compute the cost with this function, and this for the whole data set, I mean the average of the cost. Now to update the theta 0, as you can see, theta 0, it has effect on this one and in this one. So to make the derivative of this theta, of the cost in terms of theta 0, we have to take this and this into account. So how to make a derivative of this term? So this is, for example, the cost. To make a derivative of this cost, we take this one 2 he and x y hat minus y, multiply the derivative of y hat, it's 1, so it's not added here. As you can see, yeah, it's here, but here's the final formula. Now we will drive this one regarding theta 0. Theta 0, it's equal 1, and the other terms, I'm sorry, I just forgot to add the other terms. For example, plus theta 2 multiply x2 plus x3, theta 3 multiplied by x3. But all of these terms are constants, so it will be the derivative of the constant, it will be 0, except this one, it will be 1. Now here's the final formula for the derivative, partial derivative, and also it's for the x1. It's the same except here it will has x. For example, here theta 0, it will be 0, the derivative of constant is constant, and this theta 1 multiply x, the derivative, it will be x. Now, to be sure that there's different methods of gradient descent or algorithms: batch gradient descent, stochastic gradient descent, and mini batch gradient descent. What the difference between these methods? So assume that we have this, yeah, in the batch gradient descent, after computing the cost for each sample in your dataset, you can update your parameters. You cannot update the parameters except if you reach or you finish or compute the cost for each sample or for each row in your dataset. For instance, let's go back here. In this case, for example, this is the first line, and it has, for example, research and development, administration, making, marketing, and state. For the first sample, I will go back to this just to be sure if you are in a safe side. Yeah, you will compute the profit for this sample and do it also for this sample. You will try to find the profit, and for this also with these attributes. After getting the value of a profit predicted values, you can compute the cost as we saw with that formula. Now you can update, as we said, you can update the parameters after computing the cost of all samples. Now assume that you have, okay, the animation is not good. Yeah, assume that you have 100 iteration, and in deep learning it called or named epoch. And now the number of update for each parameter is 100 times. For instance, this parameter and this one and this one and this one will be updated. Yeah, let's say this parameter theta 0 will be updated 100 times in batch gradient, and also this one will be updated 100 times until finishing the number of iterations. If you have many iterations, for example 1000, also this one will be updated 1000 times. Now this is somehow very slow. If you would like to wait until compute the cost of all samples, is there any way to do it faster? Yes, this one, stochastic gradient descent. It just use one sample to compute compute the cost and update the theta, and do it for the next example. And it's faster, yeah, but number of parameters, update parameters, it will be high. So assume that we have 100 iteration, it's the same, and here we have the size of data set is 50 rows. Now for each row, this we will have to update the parameters in this case. Yeah. So now number of updates for each parameter, it will be 5,000 times. But this also the disadvantage of the first one batch, we have to wait until finishing the all samples, and this one it do it for all samples. It could be random or for the whole samples, it depends. Now this one is a hybrid between gradient batch and stochastic. So it's just divide the dataset into some batch, number of batch, and each batch contains a number of rows or samples. Yeah, here's a clear. So assume that you have the same 100 iteration, and we have in our dataset we have 50 rows. Assume that we have 5 batch. The batch size is 5. It means that we have 10 groups or 10 rows in each batch. So now the number of updates for each parameter is 1000 times. So I think this one it would be, it's not high, it's not low. So in the first one it was 100, in the stochastic it was 5000, and in this case is mini batch, it is 1000 times. So based on my experience, the most of the researchers they use mini batch. Yeah, sorry. And now how to update the parameters. Let's say for example you have this, you need to update the theta1, because theta1 it's connected to the with the R and D. So assume that alpha 1 it's 0.08, theta 1 sorry it's equal this one, and alpha is equal 0.01, and y hat minus y, you will have this one, and you will have the predicted value. Let's say it's 0.88. So theta 1 will be this one multiplied by x, this one multiplied by x, which is here, plus this one will multiply by x, which is this value, and plus and until getting the last one. Yeah, and multiply by 2, divide by n, and also this one. It's very simple, it's straightforward equation. And with theta 0, if you would like to do it for theta 0, it will be here, for example, 0.88 multiplied by 1, because theta 0 x0 it's 1. Yeah, and one suggestion or advice: before you apply linear regression, you have to be sure that your features are scaled. Let's say for example between 0 and 1, this is the best value, the best, not the best, but based on my experience is a good. And this is good also for gradient descent, to go to find the global minimum fastly. Yes, and here we go, finish. Thanks, and see you again. I will in the next some videos I will try to apply this stuff in R and Python. See you again.